Welcome to our video tutorial here on multiplying matrices. So we are going to look at two problems and we're basically going to explain how it works when you're multiplying matrices by hand. First thing we're going to do is look at the two matrices we see being multiplied together here. This first one, notice it has 3 rows and it has 2 columns. The 3 is what I have just highlighted in red. It has 3 of those rows. It has 2 columns because there's 2 of the vertical alignments of numbers. So we say the dimensions of the first matrix would be 3 by 2. The second matrix that we have in this problem likewise has 3 rows. Remember, rows are horizontal arrangements of numbers. It has 3 of those rows of numbers. And this particular matrix has 1, 2, 3, 4 columns. When we look to see if the matrices can be multiplied, what we do is we look at what's called the inner dimensions. And if those inner dimensions are equal, we can multiply the matrices. Here, the inner dimensions are not equal. We cannot multiply the matrices, so there would be no solution here. The other way of looking at this, hopefully you remember, as to how we do matrix multiplication, is we would take the first row from the first matrix with the first column from the second matrix. And if we were to pair those things up, we would be multiplying the 5 by the 2, we would be multiplying the -1 by the -1, but then there would be nothing that would pair with the -2. So those two matrices cannot be multiplied. Of course, we could verify this on our calculator. So there's this matrix menu. We hit second x minus 1. That brings up the matrix menu. And I've already put these matrices in. I've put the one on the left in as matrix B. I've put the one on the right in as matrix C. I always like to double check and make sure that I have the correct numbers. To show that they cannot be multiplied, I could simply take and get the name of matrix B, hit times, and then go and get the name of matrix C, and notice it says error, dimension mismatch, meaning that the dimensions are not appropriate for the multiplication to be performed. In that scenario, the matrices cannot be multiplied. Now we have a second problem we're going to look at, and we'll go a little bit faster through this one. Notice it's kind of the same matrices except I cut a row out here. The matrix on the left is going to be 3 by 2. There are 3 rows of numbers and there are 2 columns of numbers. For the second matrix, there are 2 rows of numbers and there are 4 columns of numbers. Can these matrices be multiplied? And the answer is going to be yes, because the inner dimensions are equal. Anytime the inner dimensions are equal, we can multiply. And the resulting matrix will be equal to the outer dimensions. So we will have a 3 by 4 matrix as the result. Now that means we're going to have 4 columns, so I'm going to put 4 blanks going across from left to right, and we'll have 3 rows. So I'll put 3 rows going horizontally. Now to fill in each of these numbers, what we do is take a row from the first matrix, pair it with a column from the second matrix, and that would fill in the blank. So first row with first column gives us the 1, 1 entry. 5 times 2 would be 10. -1 times a -1 would be a +1. Now as we scroll over, we're now going to get first row, second column. So we take first row with second column. 5 times 6 is 30. -1 times 11 would be a -11. Then we just scroll across, so we go to the next one. That would be first row with third column. 5 times 0 is 0. Negative 1 times 5 would be a negative 5. And then we'll take first row with the fourth column, and we will get 5 times 5 is 25. Negative 1 times 3 would be a negative 3. Now we're going to continue it, but notice we jumped back to the first column. So we're going to come back over here and get the first column. But now we're with the second row of numbers. So negative 2 times 2 will be a negative 4. 6 times negative 1 would be a negative 6. Scrolling over, second row with second column puts us in the 2, 2 slot. Negative 2 times positive 6 is going to be a negative 12. 6 times 11 will be a plus 66. Scrolling over, we take second row with third column. Negative 2 times 0 is 0. 6 times 5 is 30. And we'll come over here to the last column. Negative 2 times 5 would be a negative 10. And 6 times 3 is 18. Now we're going to go to the third row, first column. So third row with first column, 1 times 2 is 2. 3 times a negative 1 is a minus 3. Third row, second column. 6 times 1 is 6. 3 times 11 is 33. So that would be what we just did. Now we'll go to third column with third row. 1 times 0 is 0. 3 times 5 is 15. And finally, third row, fourth column. 1 times 5 is 5. 3 times 3 is 9. Once we have done that, we will now simplify our matrix. So let's just go quickly. 10 plus 1 is 11. 30 minus 11 is 19. 0 minus 5 is a negative 5. 25 minus 3 is 22. Then we'll have a negative 10. Oh, let's see here. 54. Mental math. We got to love it. 30. Then 8. We'll have a negative 1. 39. 15. And 14. Now we could check this on our calculator. So going back into my calculator, in matrix, I've already stored these. B, I'm going to double check. It is the matrix over here on the left. D, I'm going to double check that as well. It is the matrix on the right. And if I took second matrix B times second matrix D, hit enter, there's the result. And when we compare with what we have, 11, 19, negative 5, 22, that's good. Negative 10, 54, 38, that's good. Negative 1, 39, 15, 14, that's good. Awesome. That would be our final answer, and we know we're correct. Last thing for the video, how do you store a matrix? So you go second matrix, you come over to edit, and let's say we want to put this matrix in as matrix A. First we specify its dimensions. This one would be a 3 by 2 matrix. And then we just go and type. We have 5. Then we have a negative 1. Notice it's filling in as we go. Then we have a negative 2, positive 6, 1, and positive 3. We could just quit out. We could go second matrix, grab the name of matrix A, hit enter, and there it is. So really, matrix multiplication isn't that bad. Pair things up accordingly. Be careful with the mental math. And in the end, the resulting matrix should have the dimensions the same as the outer dimensions. It has 3 rows of horizontal and 4 columns of vertical numbers.